Hi students. Welcome to MI Academy. And today in this video we are going to study the grade 10 chapter 2, Motion in a Straight Line, in Science. If you have not still subscribed to MI Academy, then click the subscribe button, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Hello students, as you all know today I am going to teach you all, motion in a straight line. This is the second lesson of grade 10 science. As you all know, this lesson is a physics lesson. Okay, if we come back to the topic motion in a straight line, there are two components to this topic. First part is the motion. Now if you think about examples for motion, you would see this every day in your day-to-day activities. A person walking, a child running, a fan rotating, a fruit falling from a tree. These are all what you see around y'all. At the same time, if you take the solar system, the Earth rotates itself around its axis, all the planets go around the sun, they revolve around the sun. Now these are all different types of motions. If you look at them carefully, you can divide them into two main types. If you think of the fan, it rotates around its axis, the Earth rotates around its axis, the planets go around the sun, so there you can imagine that it has a motion, related to a circular path. We are not going to worry about those types of motion under this lesson, we are going to discuss only motion in a straight line. Example, a fruit falling from the top of the tree, comes down with a certain direction, the tree is the starting point of the fruit, and the ground where it falls is the ending place of the fruit. And this occurs in a certain direction. When you walk, you start from one place, and you have a destination where you want to reach. So the motion in a straight line usually occur in a certain direction and in a certain straight line path. Now we'll look at what we will be discussing under this lesson. Vector and scalar quantities. Distance and displacement. Speed and velocity. Acceleration and deceleration. Displacement time graphs. Velocity time graphs. And gravitational acceleration. So as we enter the lesson, we will first discuss about vector and scalar quantities. Now from this, if we talk about quantities, you will have experience going to a shop to buy something. You don't ask, give me some sugar, instead you ask, give me 500 grams of sugar. Or 1 kilogram of rice. So as you all can see, quantities have to be measured using an instrument. In that sense, we will measure the amount of substance, in mass. This has a unit, kilogram, grams. Same way we measure the temperature of a sick person, using degree Celsius, or Kelvin, using the instrument thermometer. As you all know, when we travel on the road, the vehicles have to maintain a certain speed limit, so in order to maintain a proper limit and to know how fast you are traveling, we use speedometer. This indicates how fast we are traveling. These are different types of quantities, and these quantities are measured using an instrument, therefore these quantities have a magnitude. If you look at all four quantities, they have a magnitude, but they don't have a direction. We don't talk about mass in a certain direction, temperature doesn't have a direction. And whether the car moves from your right to left, or left to right, or forward or backward doesn't matter. The speed only has a magnitude. The same way time does not have a direction. So they have a magnitude but they do not have a direction. These types of quantities are given the name scalar quantities. So we will see what vector quantities are. Vector quantities have both magnitude and direction. When we say push or pull, you know it is force. When you are pushing or pulling, you will do it in a certain direction. Also you will give a certain amount of force, like 5 Newton, 10 Newton. So force has a magnitude and a direction. So therefore this is a vector quantity. Then we have displacement, velocity, acceleration. These are some of the new terms you will be studying in this lesson. I will explain you them in next slides. Okay, the first topic is the distance and displacement. We will see what distance and displacement are. So here, as you can see in this diagram, there is a child who wants to start from point A, so this will be her starting point, and she wants to go to another place, which is point B. And that will be her destination. Now this child has many options. There are 3 different paths: path P, path Q, path R, and the child can take whatever path she wishes to travel. You all will have experience in school. When you want to go from one classroom to another, you choose the shortest path. But if you want to spend a lot of time walking with your friends, then you choose the longest path. So here we'll see what the child will do. If she prefers to take path P, she have to travel 320 meters. If she take path Q, the distance is 200 meters, and path R has a distance of 240 meters. So the total length of the path taken to get from one point to another will be called the distance. Now if you see all the paths, it goes in a certain design, where the direction of the path changes. So when we consider the distance, we will not be considering the direction, so distance only has a magnitude, so distance is a scalar quantity. If we take out and measure the shortest length from point A to point B, it is 160 meters. This is a straight line and it has a direction, so this is the one we call as displacement. Displacement is the shortest distance taken from starting point to ending point which travels in a certain direction. And the displacement has both magnitude and direction. Therefore it is a vector quantity. As to understand distance and displacement in more detail, we will look at the examples. The figure shows the path taken by a child to travel from home to school, so here you can see that the home will be the start, and this is the school which will be the end point. So as shown in the diagram, you can see the child starts from home, that is point A. She travels towards B is 100 meters, B to C is 400 meters, and finally C to D is 200 meters. So here the distance traveled is 100 meters plus 400 meters, and plus 200 meters. So if we add them together you will get a value of 700 meters, so that is the distance traveled by the child from home to school. But if we take the displacement, it is the shortest distance, and it depends only at the starting point and the end point. So here the displacement is from A to B in this particular direction. Here remember students, when they give you a direction saying, north or east, then you have to write the displacement with that particular direction. Otherwise you can look at the points. Here we will use the starting point A, and end point D, and also here they have marked the length. The shortest distance is 500 meters, so the displacement is 500 meters and the direction will A to D. So as you all can see, the child started from home and went to school. The distance traveled by the child is 700 meters, but the displacement of the child is 500 meters A to D. We will look at another example. A child is walking 60 meters from A to B, so here everything is shown to you in this diagram. The child starts from point A, and walk towards point B. Now the child walks another 40 meters along the same direction, from B to C. So if they tell you to find the distance, you have to add A to B, and B to C, that is 60 meters, plus 40 meters, equals to 100 meters. If you take the displacement, it is the shortest distance between starting point to ending point, that is point A to point B. So it's again 100 meters. Next the child decides to walk back again towards point A, so now if we calculate the distance you can see the child walks from C to A, that is 100 meters, so now the distance is A to C, plus C to A. That is 100 meters, plus 100 meters, equals to 200 meters. But the displacement is the shortest distance between starting point to ending point, that is point A to point C, then point C to point A. So here the starting point will be point A, and also the ending point will be point A, then the displacement will be 0. So I hope you have understood this example clearly. Okay students, I will continue the chapter 2, Motion in Straight Line, in our next video, so please subscribe to MI Academy, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Also please, like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn, quickly and easily.